Now for reduce by key, as we can see that it's again a shuffle operation, as we have discussed multiple times. If I take this same repartition RDD, in which we have got three partitions now, and the data in this word list dot text is spread across these three partitions. So once we called this reduce by key, where we are just trying to map to pair. First of all, we will get a paired RDD, in which I am trying to like map each of the word along with to a tuple with a key as word, and the value you can say as one, because it means that how many times this word has appeared in the whole text, in the whole verse list dot text. It will be give me the sum of that. For example, if I have got a string as say John, and this counts RDD will contain how many times John has appeared in the whole file of words list. This is what this reduce by keys operation is doing. Because we keep on incrementing this one to multiple by using this reduction operation of long dot sum for each of the words, it will give me the count that how many times that word has appeared. This is what it is there with the key as the actual string itself, and the value as the count. And this is triggering a shuffle if operation as well, as we discussed. So what it is going to do is, if we just again go back to here. So the first operation that Spark will do is that when we call this reduce by keys, it will try to map all the values for that particular string. For example, say John. John can be spread across multiple partitions, right? It can be here in partition 1, 2, or 3. And then the Spark will try to call the maps on each of by collecting all the values across all the partitions first, one by one. And whilst it will also try to store it into the memory, and whatever the data is, if the data is very huge, it will try to spill it over to the disk. We'll talk about persistence in the later chapter, where we'll discuss more in details about that how the data is stored in the memory and how it's still spilled over, and we can configure it as well. But here, I mean, in this context, just talk about that it will try to map all the values across all the partitions, and then finally it will try to do this reduction operation, which is count the values for each of the keys. So these are all the operations that are being done, and after this, so this is also triggering a shuffle operation, which is a little bit expensive, but we have to use this. So what I've done is that just because we already called this shuffle operation, which will take all the keys and then have the values as a count. So just let's print out the first say 5 elements by calling this take method. Now here's one thing is important here is that we are also we're using this take method because we don't want all the data across all the worker nodes to be sent to the driver node. So that's why we should use take method, which can only take a subset, a very small number of only like 5 data, and print each of them. So let's run this and see. So it has run now. So as we can see that after partition, this is same, and all these like very unique words. So for example, all iterators, I don't know the meaning of all this, but these are the words which are present there, and each are appearing only once in the whole list. So this is what it is doing. If the word is duplicated across the file, then it will be having more number of counts. So this reduction is actually taking the shuffle operation. And one thing, the last thing that we want to assert that after we call this reduce by key, was the partition changed? So for the partitioning thing, it's always inherit from the parent RDD. For this, after reduce by key, when we call this counts RDD, which is creating me a new Java pair RDD, the number of partitions would be same as the parent RDD. The parent RDD for counts RDD is repartition RDD. And as we have mentioned that this is already having 3 partitions. So the partition should be still same. So we can just assert it that whether it's same or not. So as seen here, I've just printed out that after reduce by key, partition count should be still 3, which is same as the parent RDD, which is repartition RDD is also having 3. Because reduce by key triggers data shuffle, but it does not change the partition count as RDD inherits the partition size from parent RDD. If you again run this test case, it will assert correctly. So test case has completed now. So after reduce by key, RDD partition count is still 3. So this was all about the actual code. I mean internally, as we discussed that Spark is doing a lot of shuffling operations when we call this reduce by key and all. And in the future videos, when we talk about persistence, we'll go more into details about how this data is being stored in the memory of Spark, and how it can be spilled over across various partitions on the disk as well. Okay, so this here we cover our Spark shuffles. One last thing before we conclude our chapter on shuffles: try to avoid group by key, because instead of group by key, try to use reduce by key and aggregate by key. Group by key, as you can see, that returns a data set of K and iterable V. This iterable V, right, as you can see that it can be a very, very huge iterable, huge collection of data, because in terms of big data context, if you are trying to use group by key, based on this key, there can be huge number of iterable data available. So that's why even in the API itself of Spark, it mentioned that using reduce by key or aggregate by key will yield much better performance. Because the reason is that we are, and if you see reduce by key and aggregate by key, at the end it will return a value, a final value after applying the reduction operation. The reduction option can be like sum or average or max or min, whatever. But eventually it will not result in a iterable of V. It will result in a final value. Similarly goes with the aggregate by key as well. It will not, it will actually conclude, it will actually reduce to a final value. So this was the because we cannot avoid a shuffle operation whenever we are using like wide transformation methods, but we should avoid to use group by key and other methods which are not performant enough, and use some better alternatives. So this was all I wanted to conclude before we move to the next chapter. In the next chapter, we will go to learn about Spark RDD persistence, that how the cache versus persist and the persistent storage levels. So this here we will check about all those details that we have not covered yet in the reduce by key operation. So see you all in the next video.